Okay, in this section of the course, we are going to take a look at Java 8 streams. This is probably one of the most exciting features inside of the Java 8 release. You could see if you're looking at Java popularity, it was kind of waning a little bit. So you had a spike after 6, 7. For developers, let's face it, 7 wasn't that exciting of a release. But Java 8, the functional APIs and also streams, two very, very powerful concepts. And you can see after this release, Java popularity really started resurging and continues to resurge because I personally feel a lot of it is around the functional programming capabilities that were added into Java 8 and also the streaming API, because this makes working with collections and going through collections of data so much easier. It's such a very powerful tool. And in this section of the course, we're going to take a look at some of the exciting features that we got with the streaming API. Now, if you're already comfortable with streams, go ahead and skip ahead. I know a lot of people, this is probably very new content too, as far as working with the streaming API. It's got some really, really cool capabilities, and we are going to go through that. We'll take a close look at the API, the capabilities of the Java Streaming API, and then we'll get into some really cool examples that we'll be working with and show you how we can leverage this API for working with large sets of data in Java 8 and above. All right, in this video, we are going to take a closer look at Java 8 streams. And you think of streams as a nice waterfall going through the mountains here. And it's kind of that way, but it's with data. So at simplest, a stream is a sequence of elements. So it's important to realize that it is a sequence of elements, and it is not, a stream is not specifically a collection. Collections are in-memory data structures, and the collections are eagerly computed. Streams, on the other hand, often operate on collections, but they are lazily evaluated, meaning that they are computed at runtime. So a collection of elements, like a collection of strings, that's going to be in memory right away, where the stream operation isn't going to happen until somebody actually asks for a result from that stream. So you can actually specify stream operations in your code, and as we saw before, some of the lazy evaluation stuff, it's not going to happen until Java actually sees that we need to produce a result from that stream. Now, streams can be, like I said, collections, arrays, and input-output resources. A lot of the Java collections, actually I should say all the Java collections, are included in streams. That's a real nice feature. And just as a reminder, the Java collections include set, sorted set, list, map, sorted maps, and dequeue for queuing operations. And I've also listed a lot of the implementing classes here, and I'm sure there's other classes in addition to this. So essentially anything out of the Java Collections API, we can perform stream operations on. Now there's a couple types of streams. One is just the simple stream that is going to operate within your thread and just give you a sequential stream of elements. And then the other is parallel stream. And I don't want to get too deep down the rabbit hole on that because the JVM is going to figure out some of the threading parameters. You can do some tuning there. But really use this one with caution. I see too many newer developers think that parallel equals fast, and that is not necessarily the case, especially here, because there is a cost to breaking things out. And if you're working with smaller data sets, this is probably going to slow things down. So parallel streams, I mean, you're going to be working with thousands or tens of thousands of elements before this really makes sense to use. And definitely use parallel streams with caution because it can slow things down. Your specific use case is going to be unique. If you're working with a larger data set, try it out, benchmark it, and see if it's giving you any benefit. Because parallel operations behave a lot differently in production especially on a web server where you have a lot of threads operating. So definitely use that with caution. Now let's take a look at the stream operations. There's a number of them. We've already seen some in the course so far. For each, that's going to give us an operation on each element. Map is going to be a transformation of that element. Filter is going to remove elements based on a given criteria. Limit, obviously, that's going to limit to X number of elements. And then sorted, we can sort the stream. Now, at the end of a stream operation, it's pretty common to see a collector. So I can operate on a stream and then collect that into a Java collection type. So right off the bat, we have toList, toMap, and toSet. There is also a collection and that specifies an and then I should say. And this is going to allow the collection of the result and then an operation on that result. So you can do some neat things there. We do have collector operations for joining for specifically string operations. And then we also have counting that's going to give us a count of the elements. We have collectors specifically for numbers. So this is going to apply to Java numbers. We can do summarizing, and the little XX there is specifically to the number type. So you have a summarizing double, you have a summarizing long, summarizing an integer. So that's what that XX on the slide represents. And you can do a summarizing, and then this gives you a statistical information object back. And this object is going to contain average, count, min, max, and sum of numbers. Or there's subsets of this, so you can just do averaging, summing, or min, max. So you have these different options there. So if you don't need the whole stats object, you have these more specific ones. And then we also have things that can return back a map. So we can do a grouping by, give the stream some type of criteria, and we are going to get a group by, and that group by key is going to be a key to that map, and then the map will contain elements by that key. Then we can also do partitioning by, and this is kind of a neat one. We can give it a predicate, and you'll get two values in the map, a true and a false, and then the elements that match the predicate are going to be on the true branch of the map, and then the false elements will be on the false key of the map. And then, of course, you can write your own stream collectors, and this is done by implementing the interface collector. I'm not going to get too deep on that one, but I want you to be aware of the ability to implement your own collector. So the Java 8 API does include a lot of collectors. I've never had a need to implement my own collector, so it's a pretty robust API. So I'm sure you may encounter a use case, but I want to make you aware of the ability to implement your own collectors. All right, in this video, we're going to go through some examples of Java streams. And we looked at the features in the previous video. Now let's go ahead and take a look at the actual code examples. And you can see here, we've already seen this a little bit in the class. I have a simple array list of dog names, and you can see I'm doing a for each. And IntelliJ is actually telling me that I could simplify this, that I don't need a stream here. But I'm just doing this for demonstration purposes. You can see that this runs pretty quickly. And we did talk about parallel streams too. So I got an example there. So let's go ahead and run this guy. And you can see the parallel stream example. If I run them several times, you can see how the order is changing as I run it. Sometimes the Visa is on top, sometimes he's in the middle. So that is telling us that we are in fact spawning multiple threads out there and coming back, so the stream's kind of complete in a random order. So like I said, use caution with the parallel streams. A lot of people want to jump right to it and go, oh, parallels equals fast. Not so much the case, just unless you're working with a ton of data. If you feel like you need to do it, be sure you do performance benchmarking on it. And that's all I'm going to say about the parallel streams. Now here I have a map function. Let's go ahead and run this guy. And we can see that I'm just going to map. I'm using the method reference there on line 33 to just get the length of the stream, and we're outputting the length. So the map, remember, that's going to convert the type. We also have a filter option. You can see here on line 41, I've added in a filter to see the length of 6. I think we already saw this functionality, so now we can see that I get 4 results returned back from that guy. We can also put in a limit function, so this is actually getting into some chaining. You can see that now I've gone and limited it to the first 2 results. We can also filter and sort, so these are different options that we can do. So these functions, we can put them together and build a lot of capabilities to our streams. So you can see here I'm filtering to 6 and also sorting it out. So we get the array of strings sorted out. And if you need some type of custom comparison, you can implement it there. Now here, this is where we talked about the collectors. This gets a little more interesting, where we can take that string and I'm going to filter to 6, sort it, and then I'm going to create a new string out of that. So let's go ahead and see the results of this. Now you can see that I get a list, or not a list, a single string, but everything's been concatenated together, and I've joined it in with a delimiter of a comma. So a pretty simple way to create a comma delimited string of some values. So this is a very handy tool to have in our toolkit. And let's see here, we can also do, what did I do there? Actually went to the wrong one. Now we can do additional things. So I got some functional composition here, just showing a different array of things that we can do. So here I'm coming in, I'm doing a filter, I'm limiting it to 3. I'm doing a map function, going to uppercase. I'm also sorting the result and then applying the collector. So you can see how as you get these functions with streams, you can do some pretty interesting things as you're allowed to compose these functions together to do a number of different operations on that set of elements that you're working with. Let's go ahead and take a look at this. So we also talked about having statistics. So let's go ahead and run this, and we'll see that this is actually returning back an object called this int summary stats. And if you look at this object, let's take a quick peek at that. You can see that it's got different properties on it. So you can access all these different properties with getters. So, but if you do a toString, you can see that it does have a nice output. So you get count, sum, min, average, and a max. And if you just need the max, there's also a way to do that. There's several different implementations of this. So this is going to return back an optional int, and we'll go ahead and run him. And that's just going to return back the max value as an integer. And there's actually implementations for everything in the summary, so you don't have to run the full summary. You can just run the individuals, should that be what you need. And then there's a summary collector, so you can do a sum there. So here, I mean, these two tests, they return back the same thing, and you can see that IntelliJ suggested that I replace it. That's a little bit simpler, but I'm just doing this as an example so that you can see the different contrasts, the different options that you have there. So there are tools in the API that you may not always want to be using. Now let's take a look at this grouping by. The grouping by is actually a really interesting option. So what this is going to do is going to take in this array list, and I'm doing a stream and collectors group by to set. And let's take a look at the output for this. You can see that the output, now I'm doing a set, and I'm saying to group by the length of the string. So each property in the stream, I'm going to get the length on. And then for that, I'm going to collect them into a set. So here in the output, you can see that I have 2 strings that are 3 characters long, the GSP and lab, one that is 4, that's the MUT, and then I got 4 that are 6 characters long. And you can see that I did get back a map with an integer and then a set of strings in each property of the map. So this is a real handy one when you're summarizing data. You can see a lot of uses for that. And then we have flat map. This is one that can be really confusing. It's hard to understand, but you can do a lot of things. And effectively, you're going to take in a stream, and here you can see on line 145, I have a stream, a list of lists. So I have a list with a list of integers in it. You can see I'm constructing one list as 1, 2, 3, then a second list of 4, 5, 6. And what flat map is going to do is it's going to flatten down that stream. So here I'm doing a flat map, and I'm going to return back that collection as a stream into the stream. So I'm going to get 3 elements from the first one and 3 elements from the second one. So when I get to line 149, I'll actually have all 6 elements. Let's go ahead and run that. And you can do some pretty complex things. The big thing to remember here with the flat map is you're going to be, it's kind of, I think it feels, it's a little misnamed because it doesn't quite click with me, because I want a flat, seems like we're going to be reducing something, but in fact it's the opposite. So when you go through a flat map operation, you're probably going to be getting more elements coming out on the other end. So important thing to remember, but this is a very versatile tool to leverage within the streaming API. And then finally, we also have a reduction. I don't think I mentioned flat map or reduction in the introduction video. Here we have our list of dogs, and much like the joining, I can do a reduce, and I'm passing it in a lambda. It takes in two properties, and you can see that it's going to concatenate the string together. So let's go ahead and run this and see the output. And you can see that I get one string out with dashes in between the different dog names. And it also returns back an optional, so that's why I'm doing the get method on it. And this is a handy function. And remember, this is going to be a terminal, so it's going to return back an optional, and it's going to stop the stream operation. So this is a terminal type operation for Java streams. Okay, in this video, we're going to take a look at streams, but we're going to use the reactive streams. And there's a lot of overlap between the implementation of the streaming API of Java and also reactive streams. And we're going to re-implement most of the examples that we looked at in the previous video. So let's take a look at a very simple example here. So on line 19 there, I have a flux of dogs. So if you remember, the reactive types of flux has many values. It's going to have 0 to many, where a mono is going to have 0 to 1. So here I've created a flux, and I'm using the operator just, which is going to give me a flux of strings for the dog names, just like we were looking at before. And here on line 21, I am doing a toStream method. So let's go ahead and run this, and we'll see that this does run successfully. And I get a list of the dogs. And what's important to point out is, if you recall, the flux is actually a publisher, and this is part of the streaming specification, so from reactive streams. And in Java 9, this is going to be built right into the Java 9 API, but I'm still on Java 1.8 here. Java 9 just came out last month. Haven't switched over yet. So I want to point out that this is a publisher, and when we do the toStream on it, this is going to go ahead and subscribe to that publisher and get all the values out of it. Now, there's a few different ways that we can interact with this, and I'm going to show you a few examples, and this is not by any means to be a complete option here. So we can pass in a subscriber and give it a function, that subscriber a function, and this is going to run the same way. And this is just a different way of running it, because now we're specifying dogs. We're going to give it a subscriber, and in this case, we're just using a method reference to system out. Now, if you look here, now I have one here. Let's go ahead and run this one. You'll see this doesn't do anything, and that is because I don't have a subscribe action. So just like Java streams, the reactive streams are going to be lazy as well. So because here I'm just doing a do on each, I've specified that, but I don't have any type of pressure. The subscribe action is saying, hey, go ahead and invoke the stream. So that's what's going to get the streams cooking on this one. Because without that pressure, nothing's going to get triggered. So right here on line 37, there's no line, there's no pressure to invoke that. The subscriber is what's going to give that pressure. So keep in mind, when we're working with the reactive streams, unless there's something asking for those values, nothing's going to get invoked. Now the subscriber, it's actually an overloaded method, and there's several different ways to invoke this. And you can specify this method signature here, so you can specify a consumer for each element in there, then an error consumer, and here I just have it null, and then when we are all done. So let's go ahead and run this, and now we'll get a woot all done. And you can see here, I think we had a null at the bottom of that. Let's double check that. Yeah, so here I got a null output because I don't have any when done on this guy. So I got to do on each and then subscriber, and this piece here in that invocation is null. Now we can expand this out a little bit. So I put this example in here to help you visualize exactly what's going on, because we do have types here that we are passing in. So we have our flux again on line 58. Now I'm setting up a subscriber, and that's just a simple lambda, and I'm just calling it println. Maybe I should recall it something else, but remember, it's just a reference to system out println. And then I have an error handler, and these have different signatures. So they're both implementing the consumer interface, but one takes a string, one takes a throwable. And then here I take in the error handler, and now I'm just going to do a simple message of some error occurred. Now, this is a pretty simple error handler. If you had a more complex event chain, obviously you're going to put a lot more complexity in that. And then we also have on line 67 a way to call something when our processing is complete of that stream. So when we're done with that stream of objects, we can call another process, do something else. It gives us a tremendous of flexibility. So all we have to do is do some type of runnable. Here, I'm just doing a system out to say that we're all done. And now I'm going to do this dog subscriber. So I'm going to do a subscribe, pass it in my print line lambda, my error handler lambda, and also my runnable lambda. And I want you to keep in mind that line 70 is the same as line 53. So the same functionality, just different syntax. So let's go ahead and run this guy now. And you can see that he runs the same way as well. So let me collapse a couple of these. Now we had some mapping examples. Here we want to do a type transformation. So here I have my flux of dogs. I hit enter there. And now we're going to map. So we're going to get the length. Now we're going to say do on each and then subscribe. So let's go ahead and run this. And now you can see a little bit different. So we're seeing on next and the outputs there. You can see some of the inner workings of what's happening inside of here. So we're actually getting a signal coming in, a signal object, and that's what the on next is saying. So, and the subscribe gives it the pressure, so that's what gets things flowing through that. Now, just like we did with Java Streams, we also have a filter option, and we'll go ahead and run that guy there. And see now, I've filtered out the list, and I'm getting back the 4 values, just like we did with Java Streams, but now the filter is doing this all working with reactive types. So you can see this is actually bringing back, it's taking in a predicate, and it's going to be returning back a flux. So until we get that back pressure there from the subscriber, nothing's going to happen. Now we also had a limit example, and in this we don't have a limit method, but we do have take. So we can say take 2 elements from the flux. When we run this, it's going to work just like the Java 8 stream, where we'll get 2 elements brought back. Now we can also run a sort function on that, just like we did in the Java streams. So again, we're going to take our dogs, we're going to apply a filter 6, and we're going to say take 2, and then sort it, and then apply a subscriber. So let's go ahead and run that. And we see that we do in fact get 2, and now we can see that it's been sorted properly. So if I run this here, you can see that the previous one, the Vsla is on top and the gold one's on the bottom, where in this case, we can see that our sort is being applied. And now here I'm going to show you a collector example. So we're going to go through this and actually apply a collection. And we can see that we get the same functionality there. And if I can change this to take 3. And see, this is working the same, but if I hover over these methods, you can see that we are returning back fluxes in this. And this last one actually turns back a mono because we're going to do a collection and we're going to get a mono. And obviously, when we collect and join that string, we're going to get a mono with 1 element in it. So that's why it's a mono rather than a flux. And then I say subscribe, and then I'm going to take that and print it out to the console. And we can also do flat maps. And I want to show you something here. So here I have this is just like the example that we have. We have a list of lists. So we have 2 lists inside of our list. So we have 1, 2, 3, and 4, 5, 6. And what we want to do is flatten that out. And you can see here, if I just run it once, we actually get our 2 lists. We get a list of 2 lists being outputted to console. So we get 2 elements, and each element is a list. So we want to take it a step further and flatten it out to all the integers. So if I run the flat map twice and do a flux from iterable, that works. And this is one way of implementing it. I didn't think that was very pretty, so I played around with it a little bit. And here we're taking this flux and we're working with it and we're actually taking the list into a stream, and now we're mixing the Java 8 streams and the reactive streams together here. So we're taking in that list, and technically we have the two elements, but we're taking the two elements inside of the Java 8 streams. So we're kind of getting out of the Flux world and going into the Java streaming world. And this is I'm just showing you an example of how these can work together here. And now we'll get the same interaction here. So just an option of how to do it. I didn't think that was that pretty. Here, I need to think through this a little bit more, but this section we are taking the list elements, but we are staying in a reactive syntax, and this isn't going to get invoked until the subscriber gets invoked. Now we also do have a reduce option. So here's our list again, and the syntax is almost exactly the same. I think it is exactly the same except for the subscriber. So if we come in here and run this guy, we can see that we'll get the string just like we did before. So we have string space dash space and then the next value, and it works just like Java 8 streams do. So when you're working with fluxes and monos, the Java 8 streams, the API, there is a lot of compatibility, but keep in mind, as we're working with this, we're not getting the actual hard types back. We are going to get the publishers and subscribers. Flux and monos, which are publishers, those are going to be the return types. And until we get the subscriber pushing on it, nothing's going to happen. So everything will be lazily evaluated. So even in this case here, this section of the code where I'm working with the Java 8 list, that won't get invoked until the subscriber gets pulled, and that will then get pulled in. So kind of neat how things are going to be lazily evaluated here. So I hope you can see it. I just tried to throw out a number of examples here so to get you used to working with the Flux and multiple objects coming from the Flux, so you can see how much overlap there is between the Java stream specification and the reactive stream specification. There's a lot of similarity there. Okay, this concludes this section on Java Streams. So I wanted to look at two different things. One, I wanted to get a good solid foundation on the Java Streams API. So it's a very versatile API. You can do a lot with that. Now the streaming that we're going to be working with is primarily going to be probably from the Collections API, but there are other use cases. And especially when we expand out into the reactive streams, this is going to give us a lot of interesting stuff, because now we're dealing with effectively futures, kind of pseudo futures, that have to have some type of pressure from a subscriber to invoke. So everything inside of streams, whether it's Java or reactive streams, is going to require something asking for it. So we saw that with just Java streams until we asked for something. That didn't get invoked. So remember, if when I showed you how to trick out the final variable there and use an array, and we were able to change that, so we didn't see that get invoked until that print line statement was invoked. Just like that, the reactive streams are going to be working the same way. So until we start asking for that, till something asks for that, that stream doesn't get invoked. So that's an important concept to carry forward. Now, coming up in the course, we are going to be working with the reactive streams quite a bit more. A lot more to show you there. We've really kind of I think we went through this Java stream is really good, but we really haven't got into the reactive stream. So we're going to be seeing a lot more of that coming up in the course, and a lot more fun stuff coming up in the course.